Hi guys, this is Dr. TS, and today we are going to finish Module 4 by talking about something called pH. Now before we jump into what pH is, I first want to talk a little bit about water. Okay, we've been talking a lot about water with these past couple lectures. H2O. And water can actually split into two ions. Remember, ions are charged molecules or atoms. Okay, so water can split into two ions. It can split into a positively charged hydrogen ion we often just call this a proton, and it splits into a negatively charged hydroxide ion. Okay, so this just happens naturally. Water can break into these two things, this hydrogen ion and this hydroxide ion. And because water can split into these two substances, okay, we are specifically interested in how much of this hydrogen ion do we have. So there are going to be substances that increase this, there are going to be substances that decrease this, but overall pH is looking at how much of these hydrogen ions or protons do we have. And so we can characterize solutions based on the concentration of these ions. So there can be three types of solutions we talk about. Okay, the first is an acid. This is a substance that will increase the amount of hydrogen ion or protons in a solution. So this can happen we add something like HCl, hydrochloric acid. This is a very, very strong acid. That hydrochloric acid is really likely to give away its hydrogen proton, this hydrogen ion. So something like hydrochloric acid increases the amount of this hydrogen ion in solution. So we call that an acid. On the other hand, bases are going to decrease hydrogen ions in solutions. So you can do this by adding an atom or molecule that can then take up that hydrogen proton, or you can add more hydroxide ions. Remember, water splits up into these hydrogen ions and these hydroxide ions. So if we add more hydroxide, it will then bond with the hydrogen ion and form water. So bases can take away the hydrogen ions or add hydroxide ions in order to counter the effects of the hydrogen ion. So acids are substances that increase the hydrogen ions, and bases are the substances that decrease hydrogen ions in solution. So as I said before, pH is a direct measure of the concentration of hydrogen ions in a solution. And therefore, this is an indirect measurement of hydroxide ions. So as hydrogen ions increase in a solution, hydroxide ions decrease. They kind of have an inverse relationship. So we put things with a pH on a scale. We call this the pH scale. And it goes from number 0 to 14. Now this can be a little confusing, okay? So let's kind of break this scale down into three pieces. Let's first look at this first piece, 0 to 7. We call these our acids. Remember, acids increase hydrogen ions. The smaller the number, the more hydrogen ions something has. So when we say something is more acidic, okay, more acidic, that means it's going to have a lower pH. So smaller, lower numbers means more hydrogen ions, means more acidic. So something with a pH of 1 is going to be more acidic than something with a pH of 5. On the other end of the scale, between 7 and 14, are our bases. Remember, bases decrease hydrogen ions, and therefore we see an increase in hydroxide ions. So bases, anything between 8 and 14 is going to have less hydrogen ions. So the bigger the number, the less hydrogen ions it has. So if we say something is more basic, that means a higher pH, okay? And finally, this little number in the center, 7. This means neutral. At neutral, the number of hydrogen ions is equal to the number of hydroxide ions. So we call that neutral. Finally, with this pH scale, I want to point out something about it, and that is it is logarithmic, okay? This just means that each step on the pH scale is 10 times more or less than the previous step. So let's think about this, okay? So let's compare something with a pH of 2 with something with a pH of 3. Okay, remember, something with a pH of 2 is going to have more hydrogen ions. In fact, it's going to have 10 times more hydrogen ions than something with a pH of 3. Okay? On the other side of the scale, 10 and 11. Okay? If we're looking at something with a pH of 11, we're going to say this has 10 times less hydrogen ions than something with the pH of 10. Remember, as the number goes up, the less hydrogen ions a solution has. Remember, these steps on the scale are by 10. Okay? That's why we call it logarithmic. So acids have lower pHs, more hydrogen ions. Bases have higher pHs, have less hydrogen ions. And again, this can be confusing because the numbers get smaller, meaning more acidic, and more basic means the numbers are higher. So just kind of make sure you practice with that idea. Now, why is this important to know in a human biology class? And that is because most of our blood in our body is made up of solutions that include water, right? Our body is going to have different pHs. And so because our water has different pHs, we need to be able to control that pH, right? Remember, we talked about this word called homeostasis in our very first lecture, the ability to control our body's set points. Remember, we have set points in our body. Like our temperature is 98 degrees Fahrenheit. We want to control that temperature inside our body. pH is another set point and something that our body controls via homeostasis. So, for example, our blood pH has pH of 7.35 to 7.45. So this is neutral, maybe a little basic. If our pH goes outside of this range, that is really, really dangerous for us. It can lead to severe injury and even death. And so being able to control our blood pH is super essential. And our body does this using something called buffers. Okay? Buffers are defined as substances that minimize changes to the hydrogen ion concentration. Remember, pH is a measure of how many hydrogen ions we have. And bases do this by either donating hydrogen ions or accepting hydrogen ions in a solution. So for example, you should never do this, but let's imagine that we drink a big old glass of hydrochloric acid. Okay, hydrochloric acid is a strong acid, meaning that it easily gives away these hydrogen ions. So if we wanted to, if we drink this, which again, you should never do, okay, that would not feel super great. If we were to drink hydrochloric acid, our body would have to counter the increase in hydrogen ion. And it could do this by adding hydroxide or by adding a molecule to take away that hydrogen ion. So buffers control this change so that when we're eating something that's more acidic or even more basic, that we aren't going beyond this set point of 7.35 to 7.45. All right, guys, that gives it for pH. If you have any questions, I highly recommend watching this video over again, as this is a concept that can be difficult to wrap your head around the first couple times. Thank you, guys. Bye-bye.